Hello, everyone. Good morning. Hope everyone had a good Christmas. And I'm back, taking some time off this week, but I'll be looking into, at least today, I'll be looking into LangChain, specifically retrieval rag and loaders, that section of the documentation. Um, I Disclaimer: I haven't looked at this before. I did in the previous streams, but I'm not an expert on this. So this is mostly me learning and going through the docs, learning in that way by going through the docs. Hopefully others find it useful. Anyway, let me share my screen and I'll go through the docs. There it is. Let's make this a little bit bigger. Yes, this is fine. I've also added, in case anyone wants to follow along, I've created a repo. It's empty right now, but I'll be pushing changes there as I go through the docs, in case anyone wants to follow along. If not, I'll leave it up there just for I know a lot of times I go back and refer to these things because I forget what I've done before, so it's useful for me as well. But anyway, let's get started. So let's do the, let me close this. We don't need this. All right, so retrieval is the first thing I'll be looking at. Okay, so many LLMs require user-specific data, not part of the model's training set. Yeah, I think I went through this last time as well. So if the data is not in the model, you need a way to get other data, external data, user data, whatever you want to call it. And the way you do this is through Retrieval Augmented Generation, RAG. So in this process, the external data is retrieved and then passed to the LLM when doing the generation step. So LangChain has all the building blocks for the RAG application, simple to complex, documents everything related to the retrieval, i.e. how to fetch the data. Yeah, sounds simple. It can be complex. So there's several key modules here. So source data can come from anywhere. You load the data, transform it, embed it, create embeddings, store it somewhere, either memory or a third-party database or service or somewhere else. And then you can retrieve it. So let's look at and it looks like this is separated by these verticals: loading, transforming, embedding, and then storing and retrieving. Yeah. So loaders, document loaders load documents for different sources. There's over 100 document loaders, as well as other integrations. Also provides integrations to load all types of documents, HTML, PDF code from all type of, basically anywhere, right? From what this is saying here. Once you load that data, you only want to fetch the relevant parts of the documents. So this involves several transformation steps to prepare the documents for retrieval. One of the primary ones here is splitting or chunking a large document into smaller chunks. And LangChain has several transformation algorithms for doing this, as well as logic optimized for specific document types, so code, markdown, etc. So yeah, so the transformer thing, I guess, if I take an example of some of the blog posts, like in one of the previous streams, I was trying to load my blog posts. In those, let me actually show you how that looks like, so everyone knows what I'm talking about. But I could straight up just load the markdown file. However, I have other stuff in that file. It's not just the content of the post, right? It's just not just the blog post. Let's get this one. So I'll load it here. So this is how one of my blog posts looks like. This is how it's defined. It's probably not best practice, but anyway. And there's probably a lot of stuff here that shouldn't be here in the first place. But what I'm trying to say is, If I'm trying to load data, I load my data, I load my markdown files, and I have hundreds of these, right? I need a way to transform it, because setting like this, or information like contains title image to true, doesn't tell anything, right? To It's not useful in this context, right? Things like keywords could be useful, category, uh, these are not, probably not useful, description, maybe, date, I guess. But then also the other portions, so what I would want to do with the transformer is I would probably want to ignore some of these things or clean it up. But also, I don't know how the loaders handle this, or how is this handled, but I would assume, does LangChain know that this is a H2 title, right? Does it know that this is a code snippet, right? I would say probably not. So you would have to use a document transformer, right, to transform whatever you loaded into something that's more useful, right? Okay, so I'm assuming that's it, but we'll see once we get to that one. So next is the text embedding models. So key part of retrieval is creating embeddings for documents. So embeddings capture the semantic meaning of the text, allowing you to quickly and efficiently find other pieces of the text that are similar. So it provides, again, 25 different embedding providers and methods, from open source to proprietary API, and it allows you to choose the one that's best suited for your needs. And it also provides a standard interface allowing you to swap between the models. Okay, so this is creating this is this portion here, right? Creating the embeddings vectors, right? And then vector stores, that's the next one. So once you have those embeddings, you ideally want to store them somewhere. Emerge a need for databases to support an efficient storage and searching of these embeddings. Again, integrates with over 50 stores. I think last time I used fives, which was just in memory. Well, it wasn't in memory. Well, it was in memory once you load it, but you could store it in a file. But I would assume there's other vector stores, databases out there that are maybe more efficient, or better in that, instead of just running it locally and storing it in a file. And then swapping, same thing, right? So this seems like the key for LangChain in general, is that there's a standard interface for doing these different things, but then you can also swap it out with the implementation, either models or vector stores in this case, or whatever it is. All right, and then the last part is the retrievers or retrieval. So once you have the data, once you've loaded the data, once you transform the data, once you've created the embeddings, once you store those embeddings into some sort of the database, you will still need to retrieve it. So LangChain supports many retrieval algorithms, and is one of the places where we can add the most value. Okay, so it supports basic methods, easily, simple semantic search. So that's what I did this is what I did in one of the previous streams, basically similarity, right? However, we've also added a collection of algorithms on top of this to increase performance. So parent document retriever. So it allows you to create multiple embeddings per parent document, allowing you to look up smaller chunks but return larger context. Okay, multiple embeddings per parent document. Okay, I'll have to click on this one once we get to it. Self-query retriever. So user questions often contain a reference to something that isn't just semantic, but rather expresses some logic that can be represented as a metadata filter. Self-query allows you to parse out the semantic part of the query from other metadata filters present. I'll have to click through these. So let's click through these just so I can get a better understanding of what this is. So when you're splitting, let's zoom in here. Just double check the. So when splitting documents, so there's often conflicting desires. You might want to have small documents so that their embeddings can most accurately reflect their meaning. If too long, then embeddings can lose meaning. Okay, makes sense. So if you have, okay, so you want to have long documents that the context of each chunks. Okay. So you may want to have smaller documents. So if you, let's say you have a 500 page book or whatever. I don't know what does that mean large here, right? In this case, is 50 pages too long, or is it 2000 pages too long? But anyway, so what you want to do is within that document, you want to probably create embeddings from smaller chunks, because if you try to create embedding for the whole thing, you will lose the meaning, which kind of makes sense. And then you want to have long enough documents that the context of each chunk is retained. Exactly. So what it does, it strikes the balance by splitting and storing small chunks of data. So during retrieval, it first fetches a small chunk, but then looks up the parent IDs for those chunks and returns those. Oh, so it creates like a connection, I guess, logical connection, right? It splits it, and then it gets the first chunk, but then it looks up the parent to get the larger, where that fits into a larger document. So the parent document refers to a document that a small chunk originated from. This can either be whole raw document or okay, so you can nest it, I guess. So let's look at an example. I'm not gonna run through this now, but I guess we'll get to it. Oh, it's already, it's part of the retrievers down here. I'll get through this one later, but so you load the two documents, and then in this mode, we want to retrieve the full documents. We only specify a child splitter, so recursive character. Okay, so it gets chunks the documents by 400 characters. Use Chroma as a vector store. And then uses OpenAI embeddings, and then uses an in-memory store and retriever. Okay, retriever just points to the splitter, the store that you're using, which is in-memory store, and the vector store, which is Chroma, that's created out of the like embeddings. And then you have two documents. It's now called the vector store search functionality. It returns small chunks. So similar, okay, so it's looking for Justice Breyer, and then it returns, now it's retrieved from the overall. Okay. Okay, so this is just a content. So you can get the smaller, but then you can also get the bigger section. Full documents can be too big to retrieve. In that case, when we first split the raw documents into larger chunks, then split it into smaller chunks. We then index the smaller chunks, but on retrieval, we retrieve the larger chunks, but still not the full documents. Okay, so this is the multiple layer or level, I guess. Oh, okay, yeah. So you have parent splitter, which is chunks 2000. I guess I don't know if this is characters or what exactly the number here is. And then from the parent splitter, you have the child splitter. I guess child splitter, parent splitter. Yeah, so it's the same semantic, right? The way that you write this, it's you just add the childs and parents as well, right? Okay. Yeah, and then you can get multiple, like either smaller or bigger thing. And then self query. Let's look at this one. Self querying, I guess. Let's click here. Okay, self querying has the ability to query itself. The retriever uses query to write a structured query that then applies that structured query. There's a missing image here. This allows the retriever to not only use the user input. Okay, let's look at an example. Chroma vector store. Some multiple documents. Oh, and then it has the metadata. Okay, so year, right? Director, year, director, and rating. And then the self. Now we can instantiate our retriever. We need to provide some information. Okay. And then you create the field, like you formalize the fields, right? Brief summary of the movie. You pass in the LLM, which is the OpenAI chat, the vector store, which is created from these documents, the embeddings, right, from those documents. Document content, brief summary. Okay, brief summary of the movie, and then the metadata, which is just the information about the fields that you provide in the metadata here. And then you test it out. Okay. Oh, this is awesome. This is exactly what I could do here, I guess. Right? If I'm talking about my blog posts, right? I could well, I would have to get into this format where the metadata would be like who's the author, what are the tags, what is the category, what are the keywords, what is the date, right? What is the title in the end, right? Because in some of these, I don't have a title explicitly, it's there. So I would massage the data or the raw document contents to put it into this this format, and then I could go and define these attributes, and then it's going to be I'll be able to say, for example, give me all titles of the blog posts where I guess the tags are STO or keywords. Keyword is this or author is that, right? And then it would be able, even though I'm not mentioning the author anywhere, right, in the blog post, I would be able to do this. And then the other thing, I guess this goes to the transformation section or portion. So in the transformation section, what you could do is theoretically, I just noticed I have a missing missing link here. But what I could do is, I think, if I'm reading it correctly, I could transform the document and then extract all the like YAML sections or code, if you wish, as well as the links, and then have those links maybe created as attributes or extracted out as attributes, because that way I could like search based on that information as well, right? But this is me thinking out loud. I'm not sure if that's really the case or not, and if that's how it would work or not. All right. So let's go back. Where were we? I was here, right? No, I was here. Okay, so attributes. So this was the self-querying thing. Let's go. Is there anything else here? Specific key, the number of documents to fetch. Okay, so then you can be even. But how is this? Oh, enable limit, I guess. Okay, so you can just get 2. You can reconstruct the retriever from scratch. Oh, okay. So this is how the whole prompt then looks like. So when responding, formatted JSON. Yep. Yeah. Okay. All right. So this is more advanced, I guess, if you want to do it from scratch. All right. Let's go back here, and then so we kind of understand this. So parent document, you chunk it into the smaller documents or smaller chunks, split it, right? And then you can split those smaller child chunks, if you wish, into even smaller ones, and it allows you to either return the more specific one or like the more general one if you go up the tree, I guess. I'm assuming it's a tree. Self-query retriever, you can extract the specific fields and then pass that as a metadata that allows you to filter or use the metadata, I guess, metadata in the prompt. And then ensemble retriever. Okay, so this is the combination of these. So it takes a list of retrievers and ensemble the results of their get relevant documents and re-rank. Oh, okay, so this is multiple of them. So let's see. So by leveraging, you can get better performance. Yeah, so you're getting best of all the different algorithms. So you combine a sparse retriever with a dense retriever because their strengths are complementary. Hybrid search, So the sparse retriever BM25 is good at finding relevant documents based on keywords, while the dense retriever is good at finding relevant documents based on semantic similarity. So that's the embeddings, calculating the similarity between those vectors, between those embeddings. So list of documents, BM retriever from text, doc list, embeddings. I think this is what I was using last time. So retriever k equals, what is the k here? I don't get what the k is. Is that like part of the algorithm or something? And then get relevant documents, apples, docs. I like apples. Okay, I guess maybe not the I had the best example here, but oh, this is how ensemble, and then you just pass it in. Oh, and then you can do weights as well, right? So you can give more importance, I guess, to one or the other retriever. All right. So ensemble, let's go back. And then last one, was that the last one? So there's no one. So this was the retrievers, and then there's also indexing. So LangChain indexing API syncs your data from any source into a vector store. Okay, so it syncs the data from any source into a vector. Okay, so I think let's see what is this exactly? Indexing workflow. All keep in sync. So LangChain record manager. I want to see some code. There it is. So create an index. Oh wait. So initialize a record manager. It's this one. Schema. Okay, as this is an indexing, maybe we'll probably get through it to it. Okay, so this was the last thing here. So let's go into the document loaders and look at the. Oh, let me hide this. There you go. Okay. So load the data as documents. Document is a piece of text and associated metadata. There are documents loaded for text files, web page, okay, YouTube, transcript of a YouTube video. Document loaders provide a load method for loading data as documents from configured sources. All right, so get started. So since I have this here already, let me just do a post.md. We have some data to main.py, for lack of better naming, virtual environment, virtual env source, and pip install LangChain. Whoops. Pip install LangChain. Go. And we'll get started with this one, and we'll see where it takes us. Okay, a new release of pip. Oh, let's do this. All right, so let's copy this one here. And if the font is too small, let me know. Anyone watching, I can make it bigger. So we'll load post.md. And so let's do Python main.py. Probably have to print it out. Yeah. The thing is that these docs here are actually Jupyter workbooks. So that's why I could have used Jupyter, I guess, but I prefer to do it this way. But anyway, okay, so this loads the document, and I don't think it does anything special. Just trying to see if there's, so it's document, page content. What is the sidebar? Okay, so these are already data from, like, this is the blog post itself. And I think down here there's metadata. It says source where the document is coming from. Is there anything else here? Yeah, so it has metadata source, but this one has like a sidebar. Oh, that's part of the content. Never mind. All right, so that was fairly simple to read, and that was like a that was just getting started. Oh, and then this explains different file types that you can load. So CSV file, I guess it's the same format. It's in document loaders. Are these namespaces in Python? I'm gonna say it's a namespace. Maybe it isn't. Someone will correct me probably. Yeah, same thing, but you're just reading a. But it loads it differently. Single row per document. Okay, so it creates a document instance for each row. Yeah. So let's do this. So it has page content, and then metadata is the document itself, but then also has in the metadata, it has the row value. So it loads it per row. Okay, there you go. Yeah. And then customizing the parsing, so you can customize. Oh, okay, you can provide what do you want to load, right? Which field names if you don't want to load everything. Specify a column for each row and file path. Okay, all right. That's specific to the data that you have, I guess. File directory, load everything in the folder. This makes sense. Load all the MD files. You can show a progress bar. Sometimes, like I like LangChain documentation, but some of the things are like, oh, okay, this one has a progress bar. Interesting, multi-threading. Okay, sure. Loader class, type of loader, pretty easily. Text loader, but what is the? Oh, I guess. I guess the type of the loader class, maybe this one. This is kind of a useless output here, I guess, in a way. Uh, I would think that if you're using a different loader, maybe that returns a different set of documents, I guess. So let's take a look. Let me see if I have a Python file from, I guess, one of the previous streams. I'll just use that one. There you go. I'll just copy it. Joke.py. And what we'll do is comment this out, and we'll say Python. Whoops. Python loader. Document, LangChain document loaders, import Python loader, but then also directory loader, and then loader. Oh, this will probably load the, this is just a folder, right? Oops. And then we'll just load joke.py, I guess. And then it's interesting. I don't know if this is only available for directory loaders or for everything. Okay, so docs loader dot loader dot. Oh, okay, I think I get it. Let me just try. So print this out and let's see how this looks like. Python main page content. Interesting. It doesn't do. I was expecting it maybe to have some more like metadata, but it doesn't. So how is this different from text loader? I guess I probably don't even have to use. I don't see it being any different. Looks exactly the same. But I could probably use the Python loader directly. So if I would do Python loader and then joke.py, I just want to see if it has any extra metadata. No, it doesn't. Odd. Yeah, I don't really know what the difference is here. Why would this Python loader be any different than text loader? So what I was expecting here is in the metadata, maybe to tell me, list me all the functions or something that it recognizes, all the import statements or something like that, but it doesn't. What's Johan saying? Would be great if you could bump up the screen quality. I think I have it like I don't know if I can do anything right now, but I think I have it at the highest thing possible. Sorry about that. Let me check. Yeah, I have 1080p. That's the highest, I guess. Yeah, sorry, I don't know. I can make the fonts bigger if that will help. Thanks for letting me know, though. Okay. Yeah. So what I was expecting here is to actually see some metadata that would be relevant to a Python file, right? Not just a text. But it's not telling me. Yeah, this is not telling me. Why is it different? Large list, auto detect. Okay, encodings. It's multiple tag. Okay, this doesn't look right here. So function fails. Okay, silent fail. All right, so these are more. Some more settings there. Okay, let me see. There it is. So HTML. We know what HTML is. Unstructured HTML loader. Okay. Oh, nice, beautiful soup 4. This is the parsing library. I guess it's a parsing library, scraping, whatever you want to call it. If you've ever done, scrape information from web pages. Yeah. Also, they can use that. Where was I? Use that and behind the scenes. So we'll extract the text from HTML, the page content, and the page title. Yes. Okay. So see, this is what I was expecting with the Python loader to do, right? So to have just like this one, right? If it has the page content, but then also in the metadata, it has the page title that it's extracts from the title tag. I'm assuming. I was expecting that for the Python loader. Okay. Next one is JSON. Okay. Yeah. JSON loader uses JQ schema. Use JQ package. And what does it do? Let's see. Okay, so this is just pure. Yeah, so this is the JSON, and then the JSON loader. What do we get? So metadata, sequence number. Oh, so you can provide. Oh, you can do the. Can just extract the content of the messages array. I guess, right? Just this. Right, just this specific field in the messages array. Oh, so it's using JQ, but it's other than that. I guess it's just a text loader because it doesn't have anything else in the metadata, exception of the sequence number. I guess the element element index. If you want to load documents from JSON lines file, okay, JSON-L. Yeah, dot content. Oh, okay, and you set this to true. All right. Oh, there you go. Extracting metadata. The following how to be extracted JSON loader. There are some key changes to be noted. We did not collect. We managed to directly specify the schema. Okay, yeah. So we use JQ to say, give me extract these or extract this information. In the current example, we have to tell the loader to iterate over the records in the messages field. Okay, so just saying messages field. Oh, and then you create a function. Okay, so then you create a function to pull out the information that you want to return as metadata. So same thing, but you're just saying in the messages, right? You want to go through the messages array. Content key is content. I guess it's, go back to the example, this, right? And where was I? Down here. And then you're extracting a sender name and timestamp from the messages like element, right? Sender name, yeah, and timestamp. The content is going to be the document content, I guess, and the sender name and timestamp is going to be the it's page content, and the other two will be what? This doesn't look. Oh, sorry, you're looking at the wrong one. This one, right? So page content is the actual message content, and then the metadata will have the sender's name, right, and timestamp. Okay, makes sense. Makes sense. Made it a function. So this is the function to control. Yeah. Oh, and then you can do whatever you want to do, right? You can massage this and get out times. Yeah. Basically, tell it how to extract and what to extract into the metadata. So I guess if I go back to this example, I would probably need something something for Markdown that knows how to read this or parse this or tell it extract this first from each document and then create a metadata function or something that extracts the pieces of information that I want to have as metadata. JSON structures. Oh, okay. This is just telling. This is JQ. There you go. And we're at Markdown. Okay, so let's see what we can do here. Unstructured Markdown loader. So let's try this one. So previously I just used the text loader, but this time we'll do the unstructured Markdown. I'll copy paste so I don't have to type. Go unstructured Markdown loader, and then post path is just here, right? Post.md and loader equals unstructured post path. Data equals loader.load, and then we'll just print the data. Let's see what we get out. It's going to be the same. Oh, I have to install unstructured. Unstructured. I guess it was telling me, right? Okay. Come on. Why is this taking so long? Shouldn't be taking so long. Oh, there it is. All right. So I have this installed. And now we can run it. Markdown. All right. Pip install Markdown, I guess. Yeah. So this is another PR if anyone wants to do it on the LangChain GitHub is to, let's do this. I'll take a note and I'll do it if, let's do LangChain PRs. LangChain PRs, let's just do this. Missing pip install Markdown, go there. Okay. All right, sorry. Let's go back. Let's run it again. Let's see if I'm missing anything else. Nope. Okay. So let's see, how is this different from what I got previously? Doesn't look any different. Oh, it did. Did it remove the line breaks? No, I don't think it did. It looks exactly the same to me. Yeah, it looks exactly the same. Um, but let's see, maybe there's something that we can configure additionally. Probably can't. Okay, there it is. So under the hood, unstructured creates different elements from different chunks of the text. By default, we combine those together, but you can easily keep that separation by specifying mode elements. All right, so let's see what this one does. Mode elements. Let's rerun it. Ah, okay. All right, so this one looks different now. There's more metadata here. Does it different chunks? How does it chunk? Curious. What does it use to? Oh, there's a lot of stuff. So let's do output, and we'll just open it there. Output. There it is. Okay, so page content. Narrative. Okay, so it looks like it was able to get that top section of the blog post. I'll just hide this. This one as like the first element, right? Yeah. And then for each one, it says page number 1. Oh, sorry, metadata. So it's source, last modified, page number, languages. Okay, so it recognizes language, directory, file name, and then category narrative text. Curious if there's any other categories. Oh, that's all it tells us. I was hoping there to be something more. Let's see. LangChain. Let's do this one. Is this a bug? Yeah, we do not when we create methods of. Okay. All right. So there's like a text splitter. I think that goes into the second portion of the, what was it? The transform section. We're still in the load section. Okay. All right. And then PDF. I did this last time when I was reading that, like the PDF book. So PyPDF, load and split. How does it split? Let's see how it splits this. Source. Oh, okay. It retains the page number. Okay. The advantage of this approach is that the documents can be retrieved with page numbers. Yes. Yeah. Because it's in the metadata, right? So you can, if you do like a semantic search, I'm assuming once you find the specific chunk in the document, you can also figure out or get the whatever the page number was, which then allows you to deep link onto that section or onto that specific page if you want to. OpenAI embeddings. Okay, so this is OpenAI embeddings. This is like an extra here, I guess. Using files, right, to store the thing. Does the similarity search? Okay. So it finds the documents using the similarity search, and then you can access the metadata, right? Doc.metadata page, right? And then get the first, I guess, 300 characters or something from that page. Okay. And then, you can also extract images. Interesting. Someone asked, I posted my, like the previous stream I did on Reddit. Wasn't a bad mistake, but I try not to post a lot on Reddit. And then someone did ask specifically about, well, how are you handling images? And I'm like, I'm not, but I guess this is what it explain. It there's something here, right? But I don't know what extract images does. What does it actually do? Come on. I don't see. What does it do? It's not telling me. Let's try it. Let's try this. Let's look at this document here so we can see what we can expect at least. Okay, there are 2 images, 3, 4, 5, 6. Okay, there are some images here. I don't think the document really matters that much, but I'll just use it so I don't have to. Where was I? Was it this one? Yeah. Okay, so we'll comment this out, and I have to. Oh, wait. It actually, wait. Oh, extracts images as text. Oh, okay, this is interesting. Okay. Now I know what it does. I just had to read it. Okay, so let's do this. So PDF loader. I'm assuming it's there. Extract images equals true, and then page 4. 1, 2, 3, 4. Okay, has this image. So we'll see how it explains the image. So main.py. Let's see. Oh, another one. There you go. Py PDF is missing. Let's do another one. This, and readme. Missing pip install py PDF from here. In case anyone wants to open a bug or fix it, I guess it's easier. Let's do this. Come on. Oh, maybe because it's from the URL. Let me see. I can use that same book I used last time. Let me find it. React. Oh, this is really slow. What is it doing? That document is not that big. Oops. So let's paste the book here. I'll try it with this local. Just rename it book.pdf. Don't save. What? Ignore. What? Okay. Anyway, let's do book.pdf, and let me open it just so I can see I know there's an image somewhere for sure. Well, I hope. Let's take a look. 2, 3, 4, 5. Okay. Oh, not gonna be any. Oh, there it is. What's this page? I guess 15, right? So we'll do 15. Let's see if it knows how to explain this image. It's just very. I guess it is if it's doing like OCR. Maybe that's why it's slow, but OCR is why it's not. Yeah, I'm curious how it would like extract. Maybe just extracts the text on the images. But this would be an interesting thing to do with what is that thing called? It's an open AI where it can explain the image, right? Where you can upload the image and say, hey, tell me what's on this image. That would be a better way than OCR, right? Because OCR would probably just get the text out. Anyway, it's still doing something, but it's very, very slow. And then math picks, does this one do the same thing? So someone has a just up there. I don't know what math picks is. Oh, it looks like it's a third-party service. Does it do OCR on the images? PDF. Hmm. Maybe. AI powered. Oh, it does the LaTeX. Oh, it actually converts the. Oh, okay. This is math specific for like equations. Oh, I should. Oh, that's why it doesn't return anything because I haven't printed it out. Ugh, okay, let's run it again while I'm clicking through this. MathBix and an unstructured PDF loader. Oh, okay. So this is just using either like PyPDF as a library using that one, or you can use an unstructured one if you want to. And then retain. Okay, so you can do the same thing as with Markdown. You can use the retain elements to get the separate documents for each element. Fetching remote PDFs. All PDFs fetch remote. Okay. All right, so there's a online. Oh, it's a legacy one and works specifically with unstructured loader. Okay, so if you use PyPDF, you can just uh, pass in an URL and it will work. PyPDF fumed. Okay, that's just too many of these. But how is this? How are these any? Is there any difference here, or what's the like? There's too many of these, I guess. I don't know how would these be different unless they're loading the and parsing the PDFs in a different way. But I would just go with one, have like a generic one, and that's it. PDF miner to generate HTML. Okay. PDF miner, PDF as HTML. What? All right, but this is not a chunk text in the sections that output HTML content can be parsed. Okay. So it converts it into HTML because HTML that you can then easily parse it with Beautiful Soup. Okay. All right, so this one returned, but it didn't really. I don't think it really did anything, honestly. Let's see. Is this the as a result? Oh, I need a. Of course, there was a page 14. PyMu PDF, fastest PDF parsing, detailed. Okay, detailed metadata. Oh, okay. This one is maybe. What is the metadata that we get here? Oh, come on. Oh, there's. Oh yeah, there's more. Oh, look at that. So actual page number, total number of pages, title, author, subject, keywords, creator, producer, creation date. Okay. So it's not. I mean, it has the metadata, but I'm assuming this metadata data will be exactly the same for every page in that same document, right? So by PDF directory, so you can do the whole directory loaded. Okay. Yet another one. Oh, this one uses Amazon Textract service to convert documents, PDFs into document structure. Okay. All right. Interesting. All right. So these were the loaders, I guess. Looks like there's a lot of functionality for PDFs. Let's look at it transformers now. I guess the selection of a loader. Well, first of all, it depends. Like your selection of the loader will probably depend what your the format your data is in. But then also it might depend how complex the document transformers. How complex of a document transformer will you have to configure and or create? So in some cases, it might be easier for you to do a conversion from, I don't know, Markdown to PDF first, and then use a PDF loader instead of using a Markdown loader and trying to struggling with a transformer to transform it into a format that's best for you, right? Or the use case. So I guess what I'm trying to say is yes, there's a lot of loaders, and you will pick the one. You'll pick the one that most suits your data. However, you might have to pick another one depending on the way that you want to transform the data. I don't know if this makes any sense or not, but um, anyway. Okay, so once you loaded the document, you want to transform them somehow. The simplest way is you want to split the long document into smaller chunks that can fit into your model's context window. So, and then LangChain has a number of built-in transformers. Then make it easier to split, combine, filter, and manipulate documents. All right, so let's start with the text splitters. So when you want to deal with long pieces of text, it is necessary to split that up into chunks. Sounds simple, but it's complex. Ideally, you want to keep the semantically related pieces of text together. Yes, makes sense. So if I go here, you probably, if nothing else, the simplest way would be to if something is under the same heading, that's probably related, right? So you want to keep those together. Yeah, and it could depend on the type of text. So there's this notebook showcases several ways to do that. Okay, so high levels, the text splitters work like this. So they split up the text into small, semantically meaningful chunks, often sentences. Then they combine these chunks into a larger chunk. Okay, you start combining them until you reach a certain size. You have a function that defines what the size is or measures what the current size is of the chunks as you're adding them. So once you reach that size, make the chunk its own piece of text and then start creating a new chunk of text with some overlap. Okay. So if I understand, it's going to do something like, let me see. Let me remove this YAML just so I'm trying to understand something. So if I have this piece of, that was, let's see. Oh, okay, it's good. So if I have this piece of text, if I do the chunking, so if I understand correctly, so it's gonna split the text into, I guess, sentences, 1, right, 2, 3, and so on. Then it's going to start combining them until it reaches some size. So let's say this is the first chunk. So once I reach that size, this becomes its own piece of text, and then it starts creating a new chunk of the text with some overlap. Oh, okay, so this is the first chunk, and then the second one might be grabbing this as well, right, and making it, just gonna copy paste it, right? Right, so this would be, if I'm understanding it, right? So chunk 1, chunk 2, right? And this will be the overlap, right? This sentence here will be an overlap. Okay, so there are 2 different axes along which you can customize the splitter. So how the text is split, okay, and then how the chunk size is measured. Okay, so text splitter. So the default recommended splitter is recursive character text splitter. Let's paste this here. This text splitter takes a list of characters. It tries to create chunks based on splitting on the first character, but if any chunks are too large, it then moves on to the next character and so on. By default, the characters it tries to split are on, and okay, so spaces and like new lines. Okay, so this would be, whoops, this would be one chunk, right? If I'm reading it correct, but there's a space as well, right? In addition to controlling which characters you can split on, you can also control other things. Length function, how the length of chunk is calculated, defaults to just counting number of characters. Oh, okay, so it would be, oh, okay, so I could use 300, whatever. And then it would grab the Does it count? I thought it would count the character somewhere, but it would grab the 300 characters, and then that would be the first chunk, right? Uh, Maximum size, okay, by the length function, okay, so that would be 300, whatever. Chunk overlap, maximum overlap, okay, so how many characters I'm assuming it would overlap, and then whether to include the starting position of each chunk within the original document in the metadata, so you can refer to back to it at some point. Okay, makes sense. Um, all right. And okay, so long document, we use the recursive character text splitter. Okay, and then okay, let's try this. So I'll try it with I'll just try to markdown. I don't it's the same. Shouldn't matter that much, I guess. So let's do let's do text. Is there let's do this text. So we're using the same thing. There it is. Download. Oops. I'll just copy paste. Copy a raw file, and we'll say text.text. There you go. Okay. So going back here. So we'll do, so what do we do? Recursive. Oh, okay, so this is not using a loader. This is just recursive. It's text splitter. Text splitter, import, recursive. Why am I typing this? Recursive character splitter, and then we'll open the file. It's going to be text.text. Going to read the file. And then we'll do the splitter. And we'll... okay. So splitter, and then we're saying... I'll just copy this. Okay. So we set the chunk size to 100, overlap to 20. Length function is the actual length function. And then it does include the start index as well. And then we'll do text splitter dot create documents. And then we're going to pass in that text, right? So it was this one. Do I have to do it? I have to do this? Maybe. Not 100% sure, but let's see. Let's run this. Oh, I should probably print something out. So let's do print. Yeah, I'll just print these two. Okay. Let's run it. Okay, so Madam Speaker, let's go at the beginning. So vice president. So this is the... Okay, so it grabbed the first 100 characters, right? And then it's saying it started at index 0, right? Of course, at the beginning. And then the second chunk starts with of Congress and cabinet. So it starts here, right? Of Congress and the cabinet. Congress, and so look at, there's an overlap, right? So there's an overlap here, and the overlap is 20 characters, right? And then again, it grabs whatever, 100, and it says, oh, the starting index is 82, and so on, right? Okay, so you can evaluate. Oh, there's a utility. Oh, there you go. There's a utility that can visualize it. Interesting. Oh, perfect. There you go. Yeah, perfect. So whatever I was trying to show there, this is much better. So let's do, what do we have? 100. Right. Whoops. 100, and then 20. 20 was the overlap, right? Yeah. So the first one, right? And members of, oh, wait, was it 100? Oh, there you go, like a different splitter. So we have to do recursive, right? There you go. Yeah. So madam, blah, 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 Congress and, yep. And then the second one starts off the Congress, right? Oh, why can't I do the overlap here? Oh, interesting. Oh, there you go. 20, right? It was working. Where was I? Well, not really. Oh, maybe this one is splitting at a different, like using some different characters to split at. But you get the idea, right? That's an interesting tool. Chunk viz. All right. Uh, Other transformations: filter redundant docs, translate, extract. Okay, we can perform number of transformations on the docs, which are not simply splitting the text. With the embeddings redundant filter, we can identify similar documents and filter out redundancies. We can translate documents from one to another. This, okay. So this is just for so you're not like not doing embeddings on duplicate stuff, right? Because it's useless, I guess. All right. So the next one is HTML. So markdown header splitter. Oh, there's markdown splitter as well. Yeah, we're gonna get to it. Split the text at the element level and adds the metadata for each header relevant. Okay, yeah. This is what I was thinking about at the beginning. It groups them, right, and then preserves the context. Yep. So given this, all you're telling it how to split it, right? So you're saying header 1, header 2, header 3, and then it's going to add those into metadata, right? So header 1, yep, is okay, so it's telling you this is the key and the value is the actual value of whatever the element is. Okay, so you would, yeah, makes sense. Pass header 1. Interesting. Some text about bass. Oh, it actually you can also preserve the hierarchy, right? So you have header 1, header 2, right? Header 3 in that case as well, right? So you know exactly where the document that specific text shows up, that content. Pipeline to another splitter with HTML loaded from a web URL. So recursive. So HTML splitter. So it's going to split on these 4 headers. And HTML splitter, split from the URL. And then you're creating a text splitter. And then you're actually split documents. Okay, so whatever you get, okay, so you can chain these together, and hence LangChain, I guess. However you split it with the HTML, then you can pass it through the recursive character text splitter as well. And does it preserve the? Let me see. I think it preserves the metadata. Yeah, it does. There you go. It also preserves the metadata. Structural variation. Yep. You can sometimes miss headers. Prior sibling. Okay. Yeah. So there's probably a lot of testing that you have to do here. Split by character. This is the simplest one. Yeah. Makes sense. The split based on the characters. Measure chunk by number of characters. Simplest thing. Oh, you can also specify your own separator. Right. So chunk size, overlay length is separate. Oh, and then you can say separator, right? Yeah. Nice. You can do, oh, or maybe not. Oh, it's character splitter. It's not recursive. Anyway, so it's character text splitter. Let's just try it. Why not? There you go. Yeah. Created a chunk of size which is longer. Okay. Oh, because it doesn't. Oh, okay, it's not necessarily there, right? can't split it like that necessarily, right? Okay, here's an example of passing metadata along with documents. Noted that it is split along with the document. So metadatas. How does this work then? Document 1. How does it know that it's... Here's an example of passing metadata along with the documents. Okay. Document 0. So this is combining them. Trying to understand this one. Text splitter. So it creates a document. Document 1. Where's document 2? Whoops. Sorry. And text splitter, state of the union, and this one would be what? Nothing. Okay. This one doesn't, I don't get this, but oh, this is the one that I was wondering, the Python loader, right, which didn't do anything. So I guess you could use the code text splitter to split the codes. Split the code based on the language. So a lot of them supported. But what does it do? Okay, so Python, let's take a look. Yeah. Print metadata. Yeah, but how does it split? By the function, I guess? Maybe it keeps the functions together. Looks like it, right? Let's try, since I have that file there, right? Maybe it keeps it, like, splits it at the functions. Python splitter. So this one will be Python recursive. No, it's recursive. It was there, right? Character text splitter. Oh, from language. Okay. Splitter, recursive, character text splitter, dot from language. And language is language dot Python. I don't know where that is coming from yet. Chunk size. Yeah, this isn't, chunk size doesn't make sense here, but 0, right? If it's probably not doing it by functions if you have to pass in a chunk size, right? So let's see. Where is the language coming from? Oh, there it is. Oh, from here. Language. There we go. So we have the Python splitter, and then yeah, we can load the file, right? What did I call it? Joke. It's a joke. What did I search for? There we go. This guy. So joke.py, read the thing, and then Python docs. Python docs is Python splitter, create documents, text, and then let's print it out. Let's print the first one. Oh, let's print all of them. It's not that big of a... No, that was fast. All right, so let's see. How does it do? So page content. So an import, another import. Not really, right? So this one is... Yeah, this is document. All right, so it's not what I was expecting, honestly. There's no, I don't see any metadata there either. Did I do something differently? Python splitter, recursive, character text splitter from language Python. Create documents, Python docs. All right. I was expecting this to be more Yeah, yeah. Maybe I'm misunderstanding it, but then again, maybe this is the most efficient way to do it for code and Python in this case. And then JavaScript, TypeScript, Markdown text splitter. There you go. How does it do? Yeah, let's take a look at this one as well. Is this like a language? Okay, so Markdown, and what is it called? Post.md. It's MD docs, and just want to rename it. So splitter. There you go. Markdown chunk size 60. Chunk overlap, markdown text. Okay, let's look at this one. If there's any like significant way that this is split, but I don't think it is. It's just split by like the chunk size. Where is it? Title. Well, but at least it's not. Oh no, it is. I wanted to say it's not in the middle of the like the sentences or anything, but it is. And then LaTeX, HTML splitter, Solidity. I have no idea what this is. Solidity, C#, and header text splitter. Okay, so there's a header one for Markdown. Pinecone, there's some notes, chunking strategies. There you go. And Pinecone is one of the like databases, right? Yeah, so chunking, essential, optimize the relevance. Yep, once we use, we'll explore. Okay. Yeah, you need to do embedded. Chunking is to ensure it's what is little noise is just semantically. Okay, so I guess the Python in this case, Markdown and or Python splitter, the way it splits the thing, it makes it in such a way that it's more semantically relevant that it would be for if I would just use like a pure text, I guess, or text splitter. Effective chunking. Okay, that makes sense. Lead to imprecise. We use to build context. All right. Oh, okay. So they have some guidelines here, which is interesting. We want a full paragraph for context. There's a more comprehensive. Yeah. The length. Okay. Okay. All right. So it looks like there's different multiple variables, I guess, that you have to control and or modify. I wonder if there's a there's like some benchmarks or something that it would say, oh well, for this it performs better than like if you use this size for like for blog posts, if you use this size of like chunk size and this type of splitter and this embedding model, it works the best, right? But I guess they're talking about some aspects that you want to keep in mind. Yeah, is it books, articles, or tweets, messages? And then this would then guide your decision whether, like, what type of strategy you want to apply, and or I'm assuming the embedding model that you want to pick, right? For instance, sentence models work well on individual, but a model like text embedding performs better if chunks. Oh, okay. Okay, yeah. So each, yeah. What are your expectations for the length? Okay, so there's multiple angles that you have to like think through to pick the right strategy for this. Semantic search summarization, yeah. Limit size, yeah. Fixed size chunking. This is what we went through. Content aware. Sentence splitting, many models optimized for sentence. Naive, yeah. uh, natural language. Oh, okay. So natural. This one uses a more natural language way, like to get the best context, I guess, or more meaning into the chunks. Um, Better content. Oh, okay, interesting. So there are like different ways. But I would be curious. Like, is there a guide on, like, see how one differs from another one? Oh, there you go. Look at that. Nouns. Oh, let's try this one. This one looks interesting. So it was spacey, right? So let's take a look at this one just for fun. So we'll do from LangChain a text splitter, spacey text splitter equals spacey. Oh, there's a typo there, right? Yep. Text splitter. There's either a typo here or here. We'll see. We'll figure it out. And whoops. Okay. We don't need this. We read this and we say text splitter, split text, and then we pass in the actual text. And I'll just call this docs. I'll probably have to install this spacey, so let's just do that. Pip install spacey. Okay, let's go back here. This is an interesting one. I'll include this in the README under resources. Let's do resources, chunking strategies. There you go. I'll definitely want to go back to that one and read it. All right, so let's see. What do we get back here? Maybe I have to install something else. Oh, I do. Oh, I need to actually download a model or something? Oh, probably. Let's see. Oh, there it is. Oh, download, of course. Yeah, let's download this. Okay. Do I have to? Oh, no, there we go. So we got the, what do we get back? Just one document. So this one, wait, spacey, split text, but then over here, what you could do is, I would assume that this is using the same thing underneath, right? Chunk, noun, chunks. Oh, let's see. Let's just do one. So, oops, not what I wanted. Let's run this. What? What did I run here? Oh, okay. So this is the first. Oh, there you go. We really did not find site token. Okay, so there are some warnings. So maybe because it's not a, but I wanted to get this. Like, why isn't this doing this? Let's try it directly. I'll load this. We have the text, and then instead of doing the splitter, I was expecting this splitter to do the same, right? Give me the way to like get back like verbs or whatever and phrases and context and stuff like that. But I guess it's not. So doc dot. Okay, so let's do doc. I'll just print this out and see what we get. All right, so this is just the whole, gives me back the whole doc, but then I'll do this. Same thing. I wonder if let's see. Ah, there you go. Grafana is a person. Oh, okay, so it does. Perfect. Yeah. Interesting. Interesting. Is an interesting thing to look at. Industrial trained natural language processing. Nice. But yeah, I was hoping to get the same thing with this. I don't know why I'm not getting that. So if I do it like this, well, these docs, but they won't, right? Because it's not the same. That's not going to work. So I don't know why I'm running it, but yeah. Anyway, so recursive chunking, smaller chunks, massive separators, specialized. Oh, Markdown. There you go. Markdown text splitter. You can intelligently divide the content based on the structure result. Yeah, but I didn't really see when I was using. I used this one, right? We tried this one. Let me try again, because I didn't really see that it was doing anything anything special, right? Like it wasn't really, didn't look like it was intelligently dividing the content based on its structure and hierarchy, right? But maybe I'm not, you know, maybe it's not as easy to see, right? That what's logical to me is probably not logical to the machine. So yeah, let's do all of them. Yeah, I don't know. Let me scroll up. Oops. Yeah, so yeah, I don't know. Anyway, it does. I guess we'll trust that it does what it needs to do, and it does it in an efficient way, and it knows how to intelligently divide the content, right? Best chunk size. Here are some of the pointers. Pre-process. Yeah, exactly. Yeah. You need to remove HTML tags. Selecting a range of chunk sizes to test. Short mess. Okay, so the show should take the nature. Yeah, but it's not telling me balance between. But how do I know if the balance is preserved? Are there any tests or anything that I can run, or do I have to run them myself and figure it out? Probably. It depends on the context, right? More granular for more context, and then evaluating. Okay, you can either use multiple indices or. Oh, okay. So they have. I guess Pinecone has a way to do this. All right. Diving too deep into this. All right. Header text splitter. Okay, so these were the notes, right? Okay, so as mentioned, chunking often aims to keep the common context together. Honor the structure of the document. It's organized by headers. You want to split this. Oh, okay. So you have to. So it's the same, similar as with the HTML. Okay, so I could do, but it's, yeah, markdown. Oh, but this is markdown header text splitter. So it's markdown header. So let's do markdown header text splitter. Oops. Markdown header text splitter, and then we'll say headers to split on. I guess I can just copy this. Oh, all this. Yeah, this pretty much knows what we want to do, but these are tuples, right? Yeah, header text splitter, split text. Oh, and there's no chunk size here, no, because we're using it by the headers, right? So headers to split on equals headers to split on language English. Yep, and let's print this out. Yeah, header to, and then the name of the header. Yeah, so this is useful, I guess, if you want to split it like these. And then within each group, you can then apply any text splitter you want. Okay, so you do the, okay, so you split by the header first. So this would be, let's do MD header, right? Header splits, MD header splits. So we split by header first, and then we go and do it by using the recursive character text splitter. I add it back there. We don't need these two. And then each one of those, I'll just do. Okay. So you can. That's the whole like piping one into another, right? So text splitter, recursive, character splitter, chunk size, whatever, right? I'll do it this way because we will need it later on, right? Do this, and then we do the splits, the actual splits on the text splitter, split documents, and then pass in the whatever we got. Okay, because we can pass in the documents, right? And then yeah, we can print the splits. Okay, splits. So this one will be let's look at the first one. But yeah, but this one is now different than if I would just do it by header, right? Let's see, where's one? So header 3 is here. Header 2, header 3, and then whatever the text was there, right? It was this one, right? Yeah, so it's splitted by the header. So it preserves that information, but then further, we went one step further and said, well, do it by the character as well, right? But even once we, like if we do it by the character, we didn't get the header information, but this way we got the header information and then split it by the headers, which is I think a lot of document smaller documents, but more content, I guess. So instead of doing that, we take that and feed it into the character splitter, but we still preserve the hierarchy with the headers, right? Yeah, it's more granular. Perfect. Recursively split by character. This is what we did. Yeah, I went through this one. Split by tokens. Okay. So language models have a token limit, so you should not exceed the limit. When you split your text into chunks, it's therefore a good idea to count the number of tokens. There are many tokenizers. You should use the same tokenizer as used in the language model. Tick token, you can use it to estimate the tokens used. Yeah, OpenAI, how the text is split, how the chunks is measured. Swears. Okay, so this is the same. Note that if we use, oh, no. From tick token encoder. Okay, so it's saying use, like to use that and split it. And, okay, yeah. So tick token is used to merge the splits. Oh, recursive from tick token, which is no larger on the chunk. Okay, so I could do over here. I could then say instead of recursive, wait, token text splitter, split text. No, we would. Oh, there it is. There's spacey. Text splitter. Oh, and then this would be right. We would do from tick token encoder, and I would install pip install tick token, and then run it. And this would make sure that it's right size. Yeah. And then you can use it directly. You can use spacey. That's the one. Okay, so this is just the tokenizer. So it's not the, like what I was looking here, this one, right? These are some of the specific natural language processing features that it has. But what's being used here is just as a, just for tokenizer or for splitter, right? Okay, sentence transformers, specialized text splitter, split text into chunks that fit window of a sentence transformer model. Okay, that's another one that was mentioned there. Hugging Face tokenizer. Okay, lost in the middle. The problem with long context. No matter the architecture, yeah, 10 plus retrieve brief. Okay, so you have 10 more. Okay, There's issues. You can reorder the documents after retrieval to avoid performance degradation. So there's a performance degradation when you include 10 or more retrieved documents. When models must access relevant information in the middle of the long context, they will ignore the provided documents. Interesting. Okay. But how would you know, like, how would you relevant? Okay. You would reorder it like this. Oh, okay. Get relevant documents ordered by relevance score. Long context reorder. Okay. And then when you do reorder the relevant documents, uh, okay. I guess this is a specific issue. Let's go here. I'm going to read through this paper, but how language models use long context. Okay, so I guess they're not that good with using long context, but there is a way so you can reorder them to fix this. All right. What's next? Okay, next one is retrieval. Is this the last? Yeah, this is the last section, right? Oh, wait, no. Why did it throw us? So transformers, document loaders, document transformers, text embedding models. This is the embedding. I went through the embeddings before on the first video, I think. I'm not going to go through this. And vector stores. Let's see. Yeah, I've been going for like hour 40. I did this last time. Yeah, so once you split stuff, you can then store it, right? And then do the similarity search. Okay, and then retrievers. So let's look at the retrievers. The last thing to look at today. Okay, so retriever is an interface that returns documents given an unstructured query. It is more general than a vector store. Okay, so retriever does not need to be able to store documents, only to return. Vector store can be used as a backbone, but there are other types of retrievers. So they implement the runnable interface. Okay, so you can like batch them and stream them and whatnot. So retrievers accept any string query as an input and return a list of documents as an output. So this is just getting the documents back, right? So we'll use Chroma to vector store backed retriever. Okay, and we're using, okay, so let's go through this one. I'll call the file retriever.py. Oops. Terminal, and we'll install chroma.db. We do have state of the union text file. I call it text.txt. And then this first portion is what we've already done before. So this is opening the file, which we call text.txt. Use the text splitter, and then just split the text. So we've done that, right? I'll just run it, just why not, right? Python 3 retriever. So this should just, yep. So we've done that. And then what we're using next is AI embeddings, and then creating the embeddings. And I think I'll have to set up my API key again. This will probably fail. Just want to know, yeah, open API key. So let me do that really quickly. So I'll do OpenAI key. API. I have way too many keys. What? I have to do a puzzle. Okay, so what? These puzzles are so like move the train. Okay. Oh, it was there. Sorry, I'm solving a puzzle because OpenAI is not allowing me to log in. What? I can't. What the? Oh, it's there. Oh, okay. Oh, I just got what I had to do. It's weird. Anyway, I think I've. Oh, one more. Oh no, I have to try again. All right. I think I got it now. It's like X and Y axis. You have to put something in the right cell. There I go. Okay. How many of these? Yay! Proven I'm a human. There I go. All right. So I have the key. Let me just move this off for a second, and I'll do open AI API key. Paste that in, and we can try again to make sure that it works. Okay, I'll open AI, of course. Open AI, but at least now it's not complaining about the API key. So we have that, and then we'll invoke the retriever. Let's just make sure it's not going to do anything right now, I guess. Go. Okay. And what we'll do next is we'll invoke the retriever with a query. So what did President say about Ketanji Brown Jackson? And then we'll output the page content. I go and we get the same response back. Okay. So beddings, comma. Okay. Okay. And then we could probably store this, right? Yeah, you can compose them as well. So retriever. Question. Oh, okay. So I think I went through this before, but but in a different context, right? So let's do this. And template, answer the question. Yeah, I think I did this with either PDF or something. So we'll do the chat prompt. So let's do here prompt, chat prompt, and then we have format docs. It's just joining all the docs. Okay, and then we have a chain. And we don't need this. Comment this out. So context is going to be our, where was my retriever? Oh, it was my retriever. That's the context, right? Which is whatever's in the text file and creates the embeddings. We're going to format the document though by going through the page content and just joining it by new lines. And then the question is going to be whatever we're going to ask. Prompt, right? The model is chat OpenAI, and then we're just going to parse it. So let's do this. Let's say, what did the president say? And then it's going to know how to retrieve it and answer the question, right? And then I could, well, I have to print it out, right? Yeah. Just print out. There you go. Yeah. And then I could, if I wanted to remove, okay, so let's see. So we have if I take the markdown stuff that I had before, let's do this right here. And what we'll do is let's close this a little bit. So instead of loading the file, the text file, I will load my markdown post. I'll split it on the headers. So I'll include this one here, and we'll include recursive one here. Using the tick token encoder, we'll create the splits. Let's call it texts. That's what we called it up there before as well. And then we'll use that, right, from text. We'll do, everything is going to be exactly the same, but instead of that text, it's going to be the blog post. But then what can I ask about this? So let's see. Redis is used to store rate limit. Can I use Redis? Yeah, let's ask that. Can I use Redis to store rate limit counters? Where was it? There. How can I use Redis to store rate limit counters? So let's see what we get back. Let's run it. What did I miss? What am I missing? Embeddings. Special. Oh, maybe because it's markdown and that's why it's complaining. But it shouldn't, right? Text splitter, text. This is exactly right. Split text. Oh, what if I just do split text instead of tick token, if that's the one? Oh, chunk size. Oh, this one doesn't have, oh, because we use character. So let's do character instead of the recursive one. Yeah, let's do character. So it's the same. Why is this unexpected? All right, so let's do character text split. Oh, of course, it's not split text. Split text. Split documents. Oh, maybe because I get the documents back or something instead of text. Yeah, probably. Yeah, because this one is now expecting the text to be there. Yeah, so let's, I guess it just tells you that the data needs to be massaged and made in such a way that it fits the, there you go, right? Yeah, so the chunks, you can use Redis to store rate. Yep, there you go, right? That's the actual answer. All right, let's look at this briefly. Multi-query retriever. Distance-based vectors represent queries in high-dimensional distance retrieval might produce different results with subtle changes in query wording. Okay, yep. So multi-query retriever automates the process of prompt tuning by using an LLM to generate multiple queries, interesting, from different perspectives for a given user input query. For each query, it retrieves a set of relevant documents and takes the unique union across all queries. Okay, so this one is, it's multiple perspectives. Okay, so it gets like a better answer, right? Yeah, let's try this. I think I don't need the web-based loader because I have that. We can do recursive character text splitter chunk size. Let's do 500. Let's do overlap of 0. And then vector DB chroma. Oh, that's what I messed up before. Okay, let me fix this. I want to try it. So split documents. This is what I was getting an error before, right? Because it was documents, not text, right? So it was failing. Oh, why isn't it now failing? Oh, it was recursive character tick token encoder. This one was failing. I was clicking on do, yes. Split documents, and then chroma is not from text. It'll be from documents, right? And then the documents are these text, and then embedding equals embeddings. Okay, and then everything else should be the same. Let's see. I don't know. Oh, embedding typo. There you go. Yeah, perfect. So you can use Redis to perfect. How can, and that was the question, right? How can I use Redis? What is something else that I can ask? Let's see. Something that's relevant here. I don't know. It's been a while since I wrote this. So StatsD. How do I set up StatsD? I don't know. Let's see. Here, how to set up. See how good it is. Okay. Oh, okay, and then we can try this multi-query, right? Retriever. Oh, nice. It does actually. Wow. It does figure it out. That's good. So, okay. So with the multi-query retriever, you can specify LLM and retriever does the rest. Okay, perfect. So, so you do over here. So instead of doing a retriever like this, just from the database, you would do, I have chat OpenAI. So let me move the chat OpenAI here, and LLM is the model. And then this will be a retriever, DB as retriever. And we'll import this one, retrievers from LangChain, chain retrievers dot multi-query import. Why am I typing this? Okay. Multi-retriever from LLM, retriever from LLM. Oh, we can do the logging so we can see. And then instead of having, I don't need this one. So let's comment this one up. I'll take this one and paste it in here. And then we can, yeah, do the logging so we can see what it does. And okay, so this will be the same. So we should still get unique docs retriever from LLM. I don't even know if this should work. So let's try. I think this is just an extra thing that we can right, get multiple. Yeah, there you go. So look at down here. So this is from the logger, right? So the queries that are generated are, what are the steps to configure StatsD exporter? So mine was how to set up StatsD exporter. Can you provide a guide on setting up? What is the procedure? Perfect. Yeah. So it gives it like improves your prompt in a way, right? In order to get a better response back. Even though I'm assuming the steps are the same, right? Because the data came from the same thing. You can also, okay, you can also provide your own, right? If you want to, your own prompt. Nice. Contextual compression. No specific will face. Yep. You don't know what the users will ask, of course. Yep. So the passing the filter lead more. Yeah. So contextual compression. Okay. So you don't know what the user will ask. You don't know what the queries will be, which means that the relevant information for that specific query might be somewhere like in some portion of an irrelevant text, I guess. However, passing all that through will costs money, right? It's going to throw off everything else, right? So contextual compression is meant to fix this. So instead of immediately returning retrieved documents as is, you can compress them using the context of the given query so that only the relevant information is returned. Compressing here refers to compressing the contents of an individual doc and filtering out documents wholesale. So, okay, so base retriever document compressor. So the contextual compression retriever passes queries to the base retriever, takes the initial documents and passes them through the compressor. Okay, so what is foo? Base retriever, contextual, okay. And then it gets the best one, I guess. Helper function for printing. Okay, this is just the printing. All right, so let's see. Yep, so it chunks it, it reads the documents. Document one. Oh, okay. Oh, okay, so it splits it into multiple documents. Yep. Contextual compression. Okay, so now let's wrap the base retriever with contextual compression retriever. We'll add an LangChain extractor, which will iterate over initially returned documents and tracks from each only the content that is relevant to the query. Okay. So compressor, that retriever. So the question stays the same. And now you're going to, oh, okay. So it gets the documents that are specific. So it goes through the documents and say, give me just the documents that are specific to that query. And then you can actually say, run the question against these two documents, right? Interesting. All right. Well, we're up to 2 hours. This feels like it's a more, what else do, I think there's a last one. Oh, there's a couple. Okay. Ensemble, retriever. Yeah, I think I looked at this at the beginning. Multi-vector, multiple vectors per document. Okay. So instead of one, you're smaller. Okay. Parent document retriever. I think we read through this at the beginning as well. Self-querying. These are the attributes, the metadata, I guess, not attributes. So let me also add this here and say, and there's a missing image on this page. Someone can fix this. Time-weighted vector store. All right. Vector store based backed retriever. I think we looked at this one. Web research retriever. Okay, so you can load the URLs. Interesting. And the last one was indexing, I guess. But anyway, it's been 2 hours. So not going to bore you with this anymore. All right. Well, hopefully it was useful for whoever's left watching. It was definitely useful for me. I'll push the changes to the repo in case anyone wants to like take it further or play with this. I'm not gonna put that book in there. I'll leave the blog post in there. Why not? And then the text is from the internet anyway. And I'll just do code changes. I'm just pushing it right now. Commit code changes push. Yeah, so if you want to take a look, go to LangChain-rag-loaders on my GitHub, and you can download the code. You can play with the code there. I just hope I didn't commit any of the keys. I probably didn't, but anyway, thanks everyone for watching. See you next time.